All right, guys, we are going to solve system of two equations. I'm looking at the worksheet that I gave you. I'm going to do a couple of problems with you. Solve system of equations. There are three methods, but I really wanted just the elimination. Okay, just the elimination. So I'm going to do problem number 15 with you. It says 8x minus 6y equals to negative 20. And then it says negative 16x plus 7y equaling to 30. So in the elimination process, we would like to eliminate either x or y. And it really doesn't matter, you choose. Sometimes there's easier ways of doing this by saying, oh, look, if in order to cancel, first and foremost, the number at the top and number at the bottom, they have to be the same. And second of all, one has to be positive, one has to be negative. So if I'm looking right here, if I multiply the top by 2, I will get a positive 16x and I have a negative 16x. That gives me the same numbers. Now, if you want to get rid of the y's, you might say, what goes into 6 and 7? Well, we don't have to think that much. You could just multiply the top by 7 and the bottom by that 6. And since once one of them is negative and one is positive, you don't have to do anything on the outside. So I'm going to choose the easy route and multiply the top by 2. So that gives me 16x minus 12y equals negative 40. I didn't do anything to the bottom, so I'm going to keep that the same, negative 16x plus 7y equals to 30. And now I'm going to add those two together. As you see, when I add, I just eliminated the x's. And I end up with a negative 5y equaling negative 40 plus a 30 is negative 10. So y is equal to 2. And now all I have to do is plug in y to be 2, choose any of the original, either the top or bottom, and plug in y to be 2. I'm going to do the bottom one. Negative 16x plus 7 times 2 equals to 30. Now let's just do the math. We get negative 16x plus 14 equals to 30. Subtract the 14 from both sides. And we end up with negative 16x equaling to a, what is that, 16? Dividing by negative 16, x is negative 1. So my ordered pair is negative 1, comma 2. All right, I'm going to do number 19 next. It states negative 4y minus 11x equals to 36. And we have 20 equaling negative 10x minus 10y. All right, in order to do this, we know we have to have x's and y's on one side. We have x's and y's over here, but I'm just going to flip-flop them. Here, you actually have x and y, so I'm just going to flip-flop this whole equation over here. So if I flip-flop these, I get negative 11x minus 4y equaling to 36. I'm going to flip-flop this whole thing. I'm just going to take these and just rotate them. I end up with a negative 10x minus 10y equaling to 20. All right, so now it's your choice which one you want to get rid of, x or y. Well, you know what? It really doesn't matter. Since I did x on the last one, let me do y on this one. Well, between 4 and 10, I can sit here and think, okay, what number? I know 20 does, but if you didn't know, I would just multiply the top by 10 and the bottom by 4. But since one is negative and the other one is negative, they're not different signs. One of these signs has to be a negative. So, and it doesn't matter, you choose. So I might multiply this whole guy. We know we're going to multiply by 10. This is by 4, but I got to choose one of them to be a negative such that when I distribute, one's positive, one's negative. And it really does not matter. So I'm going to choose negative 10. So let's multiply out. 11 times 10 is 110x. Negative 4y times negative 10 is 40y. 36 times negative 10 is negative 360. Do the same thing with the 4. I get negative 40x minus 40y equaling to 80. And now I'm going to add. As you see, I just eliminated the y's. 110 minus 40 is 70. 360 minus 80 is 280, but that's negative. Okay, dividing by 70, x is negative 4. We go back to one of the original equations and plug in x to be negative 4 and solve for y. It really doesn't matter. I'll do the top again. Negative 4y minus 11 times negative 4 is 36. Do the math. Negative 4y plus 44 is equal to 36. Subtracting, negative 4y is equal to, what is that? Negative 8. That gives me the 44. So y is equal to 2. So my ordered pair is negative 4, 2. And finally, number 21. We have 0 equaling negative 2y plus 10 minus 6x. And we have 14 minus 22, excuse me, 22y equaling to 18x. Again, I'm going to take here this x and y, I'm going to put it to the other side. So I end up with a positive 6x, a positive 2y equaling to 10. I'm going to take this 18x to this side and this 14 to that side. So I end up with negative 18x minus 22y. And this positive 14 over here becomes a negative 14. So as you see, I'm going to multiply. See, 6 and 18, I could just multiply by 3 and one positive, one negative, or I can multiply by 11 and get rid of the y's. I'm going to multiply by 3. That's a little bit easier. Multiply this by 3. So I end up with 18x plus 6y equaling to 30. The bottom stays as is. We didn't touch it. So that cancels out the x's for me. So I end up with a, negative 16y equals to 16. So y is negative 1. Go back. I need to solve for x. It really doesn't matter. Here, I'll take the bottom one. 14 minus 22 times negative 1 is equal to 18x. 14 plus 22 equals 18x. I get 36 equals 18x. So 2 is equal to x. So I have my ordered pair to negative 1. All right, so this is solving a system of equations with two variables, something that we've done in Algebra 1. I hope this will help you out. And hopefully tomorrow we'll do 3 variables.